How are we doing, class? Today is Review for Exam Lesson 3 or Unit 3, quadratic functions. So first thing we got to remember, folks, is that when we went back to do quadratics, remember that the graph will produce what's called a parabola. Okay, and based on which form of the parabola you get, there are 2 or 3 different pieces of information that are important. So if I just maybe sketch this like this, ladies and gentlemen, have this as my axes, X and Y. I'm going to go through each form and tell you what's important. Make sure for your exam, folks, that you know these. This will not be on your formula sheet. You need to know these. Okay? So first of all, standard form, that's where you're given the y-intercept. So on a graph, it's where the parabola hits the y-axis. Okay, and there may be cases where it does not hit the y-axis on your visible graph, but there should be some indication in visual form. It may be at 0, but it must exist in some point. Okay, which may not look on the graph, but it will exist. Okay. The next form of the quadratic is the vertex form. The vertex form is given where it's DC or H and K, whatever you want to take a look at, and that is at the vertex. Okay, that's the turning point. That's the only part on the parabola that does not have a matching symmetry point. Okay, that's also going to be the indicator of the point of where it's a maximum or a minimum depending on the direction of opening. And the last form we took a look at, folks, is factored form. And factored form is where the R and the S are what we call the x-intercepts, the roots, the solutions, or the zeros. And that is where, on your graph, it hits the x-axis. Please be aware, folks, that if you cannot factor it, or you're using quadratic form, you get a negative under the square root sign, the option could be that there may be no solution. So if there's no solution, your graph's going to look like this, where vertex is above the x-axis and opens up, or it's below the x-axis and opens down. And if you're using quadratic formula, you will notice you get a negative under the square root. Okay, so just remember, for factored, for the x-intercepts, you could have possible 0, 1, or 2. Okay, no solution means 0 intercepts or 0 solutions. Okay, just remember, folks, A appears in all 3 forms. If it's not given a specific number, remember it's 1, because A, if it was 0, would not exist, which means there'd be no step pattern, which means, guess what? You wouldn't even be having a quadratic relation. Okay, so it needs to have that step pattern. Okay, and A is the same in all 3 forms, which tells us A, the vertical stretch. So if A is greater than 1, it is a stretch, and it's a compression if A is between 0 and 1. And remember, I put the absolute value of A down because the negative value or the positive value, i.e. the sign of A, will tell you if it reflects the x-axis, which is the third part. And also remember, folks, that if you're graphing a quadratic, it's easy to remember the step pattern, A times 1, 3, 5. All right. Please, if I ask you for transformations, don't just tell me that there's a step pattern of, for example, if A equals 2. If you tell me the step pattern is 2, 6, 10, you would tell me that you could identify that, but then tell me that that means that it's a vertical stretch by a factor of 2. Okay. So the transformation part or translation information is this one. Transformations is this one. I'll put T here and T here. Those are your transformation informations. Okay, the step pattern is helpful when you graph. It does not really, it helps you decide if you've got a stretch or compression in the vertical sense, but it's not what you would list under a transformation. All right, moving on. Number 2, min and max values. Hey, in order to get the min and max values, you need to find the vertex. And in many cases, if vertex form isn't given, you are going to complete the square. All right. Okay, if the parabola opens up, that means A is positive. There is a minimum. Looks like this. So a minimum value. And if the parabola opens down, or A is negative, that means we've got a maximum. All right. And then remember, folks, we have to know how to convert from one form to another. So from standard to vertex, I just mentioned, complete the square. Remember in your margin, that's your b divided by 2. And then you do your b divided by 2 and square it. Okay? That's what completing the square is. If it's in factored form, you take your zeros or your x-intercepts and you add them up, divide by 2, which will give you your axis of symmetry. That's what this is. Okay, and then you would take that and sub it, say the value of that axis, sub it into your formula that's given to find y. Let's do an example here, folks. All right, so it says, find the min-max value of this expression, f at x equals negative 3x squared plus 2x minus 7. So what do we need in order to get a min-max value? Hopefully you realize you need vertex, because that's where it's located. Okay, and so what are we going to do there? Therefore, we are going to complete the, I'll use a short form here, square. Complete the square. Okay, so start with f at x. If you want to change it to y equals, that's okay. But function notation is still fine. Step 1, ladies and gentlemen, is to take a out of the first two terms. So a is negative 3. Okay, watch your sign here. That's going to be minus 4x. Leave the negative 7, leave the constant by itself. Okay. Then what we do, folks, is we got to figure out, hey, we're trying to get a perfect square in the middle here. We need that magical third term. So we do that side work, which is b divided by 2. So that's negative 4 divided by 2 equals negative 2. And then we take that value and we square it. That's the number that we add and subtract inside the bracket. So this is going to equal negative 3. X squared minus 4x plus 4 minus 4. Those are the two we added in. Subtract 7. We have to add and subtract to keep it balanced, right? Remember that we need the first 3 to complete that perfect square. So leave the a out front. So that's going to be x. And if you're not sure what value goes in there, it's right there, minus 2 squared. Don't forget, folks, when you take this negative 4 out, because it doesn't belong, you got to multiply it by the negative 3, so that's going to be plus 12. Okay, and then don't forget minus 7 is still here. Okay, and collect like terms, and we are done here. So f at x equals negative 3, x minus 2, all in brackets, squared, and collect like terms, plus 5. Okay, so we know automatically our vertex is 2 and 5. Remember, it's the opposite of inside the bracket here. Okay, so we know our optimal value is 5, but we got to decide if it's a minimum or maximum. So first of all, what's the sign of a? Okay, so a is negative. Therefore, do we have a min or a max? Therefore, we have a max. And because our optimal value is 5, you're going to say, therefore, max of 5. And if it asks you when it occurs, you can say when x equals 2. All right. Cool. Another thing to remember, if you haven't forgot, if you could use vertex HK or that equals vertex DC, depending on if you were thinking about transformations. Those equal, the first thing is your axis of symmetry. So the first value here, those tell you your axis of symmetry. But your second value is your optimal or min-max value. So your optimal value is either your C or your K. Awesome. All right, so that is dealing with the forms of the quadratic. Now let's do, and converting min-max values, switching forms. So now we're going to deal with operations with radicals. Okay, so number 3, operations with radicals. Okay, so it says express as a single radical. Okay, so what we try to do, folks, is try to say within the square root, do we have any perfect squares that we can pop out? Okay, so first of all, actually, we're multiplying, so that's a different approach. I thought we were adding, so just give me a second on that. So what we have to remember, folks, is if you're not sure how to deal with radicals, kind of relate it to algebra, because you're probably more comfortable with algebra. So if I had 2a times 3 B, what would that equal? That would equal 6AB. The only thing is about A and B, in our case, is those are under what? The square roots. So we multiply 2 times 3, which is 6. And under the root, what is 4 times 6? That is 48. Now we look to see if we have any perfect square inside here. And that's where you can use your matrix if you want to have that for your exam, no problem. So I would have that times table with the diagonal highlighted. If you need to see me for one, I've got many in the classroom, so just ask. And what's the biggest square root that you can take out of equal factor of 48? That's 16, so it's going to be 16 times 3. Okay, so the perfect square is the 16. When you bring it out, it's going to be 4, so it's going to be 6. I'll just show this, 4, and then times root 3. Or you can go right away, folks. I don't need that middle step to say 24 root 3. I just wanted to make sure for those people who are doing the review if they understood where that came from. Okay? Just remember, if you're not sure, hey, what are my square root numbers I'm looking for? 1, 4, 9, 25, 36, etc., right? On that diagonal. Okay? All right. B, express as an entire radical. So what we need to do is bring them all inside the square root. Okay? So what we need to realize is that, hey, root 7 is already in there. But how do we express 3 as a root? Well, we got to times it by itself. So you got to say, hey, 3 times 3 is 9. So then you take root 9 times root 7, which is root 63. You're working backwards to what you just did above there. Okay? This one's a little harder. B is harder, or the second one's harder because there's a plus sign. Okay? So you have to do things a little different. Okay? These are not what we call like radicals, so we cannot add or subtract them. So we're going to try to see if we can put them into mixed form so that we then can add them. For example, if we break apart root 12, we notice that's 4 times 3, where 4 is a perfect square, right? Plus, let's break apart 27 into 9 times 3. Okay, and I always put my perfect square out front. So what do I end up with? When I take the 4 out, it becomes 2 root 3. Okay, plus I take the root 9 out of that part, and it's going to be 3 root 3. Notice now these are like radicals because they have the like terms here. So then you can add them. So now we have 5 root 3. And since we now have the terms together, now we can do exactly what we did in example A, which made that root 25 times root 3, and that equals root 75. Okay? That's a little harder one. All right. And the third one, ladies and gentlemen, and this still tends to get people even in grade 12. The problem here, folks, is when you look at the denominator here, it is in a root form. Think about a pizza. Okay? You can have a whole pizza, no problem. But can you divide a pizza into 6-point root 3 parts? No. So you have to do something called rationalize the denominator. Okay? So rationalize the denominator. Just going to use denominator, denom for short form, okay? So what we need to do is say, how do we get this radical out of the denominator of the fraction? Well, you times it by itself. So you got root 2 here, so you're going to go times root 2. Whatever you do to the bottom, you do the same to the top. We're only doing it to the term that has the radical. We're going to leave 2 root 3 as it is. Okay? So what do we end up with? We've got 2 root 3 plus, on the top now I got 5 root 3, oh, I apologize, root 2, my fault, let me rewrite that. Okay, 5 root 2 over the denominator. Let's think about that. Root 2 times root 2 is root 4, and root 4, square root of root 4 is 2. So a root times a root cancels each other out, so it should be 2 times 6, which is 12. Okay? Notice these are not like radicals, so we have to get a common denominator here of what? 12. So you're going to times this by 12 and times that by 12. Okay? So what we end up with here is 24 root 3 plus 5 root 2 over 12. Okay, and notice, folks, because the radicals, root 3 and root 2, are not like radicals, we can't go any further. So this, I'm just going to put down, can't go further. Two reasons. One, because the radicals are not like radicals like they were in the second one where you could add them here. However, the also thing is they're in its lowest form. We have no other square roots we could take out to try to see if we can get the radicals the same. All right, 4, solving quadratics. In order to solve quadratics, remember you would need to find the roots, zeros, x-intercepts by 2 methods, factoring, okay, or quadratic formula. My general rule, folks, ladies and gentlemen, is I would spend maybe 1-2 minutes seeing if I can factor because it usually leaves less error. If not, go right to quadratic formula. However, if your equation automatically has decimals in it, I would go right to quadratic formula. I wouldn't try to do decomposition with it or whatnot, or different types of factoring. I would go right to quadratic formula. All right, I will tell you, ladies and gentlemen, that this quadratic formula here will be provided on your exam, on your formula sheet. So on the exam formula sheet. So you don't need to memorize that one. The 3 up above, the 3 different forms you do, but not this one. Okay? All right. So it says here, solve for these examples. So for A, how about we do factoring? Okay? In order to factor, ladies and gentlemen, you have to have all terms on one side. And in order to solve, you're going to have to let one side equal 0. Okay? All right, so according to this, ladies and gentlemen, we need to take this negative 2x over to this side. So you're going to have 3x squared, I'm going to put it in order, plus 2x, change the sign, right? Minus 8 equals 0. Look to common factor. Can we common factor in this case? No, so let's take a look at our product. Our product is A times C, so 3 times negative 8, which equals negative 24. And our sum, ladies and gentlemen, is B, which equals 2. Okay, what two numbers match that scenario? Negative 4 and 6. And because this is decomposition, you split that middle term, okay, into negative 4x and plus 6x. Okay, and you write the first and last term just as is, and it's still equal to 0. Okay. Now what we need to do is remember, guys, it's called factor by grouping. So what's common in the first two terms? Hey, I see an x. So I'm left over when I common factor out an x, I've got 3x minus 4. Looking in the second bracket, or the second two terms, what's common there? I see a positive 2, so plus 2. What's left over? 3x minus 4 equals 0. We're almost done here, folks. Notice here we have a common binomial. Right there. So it's 3x minus 4 is our common binomial, and the leftovers is x plus 2 equals 0. Now that we've got our factors done, now we have to do what's called the zero product property. To get left side to equal to the right side, that means one of these brackets or both of these brackets have to equal 0. So you can set up a t-chart if you want. So it's 3x minus 4 equals 0. 3x equals 4. So x equals 4 over 3. Or the other one, x plus 2 equals 0, therefore x equals negative 2. Please circle your final answers. Just makes it a little more organized and neat. Okay? So that was a method of factoring, and that was called decomposition. Okay? Because a does not equal 1. Remember, in order to have simple trinomial factoring, a had to equal 1. But in this case, a equaled 3, and we could not divide everything by 3 to eliminate it. All right, example B. Taking a look at this example, hey, everything's on the one side. Let's quickly do our product and sum here. So our product would be simple trinomial. So product is just C, which is negative 3, or A, which is 1 times negative 3 would give you negative 3. And sum equals 4. Well, hey, what two values can give you a product of negative 3? 1 times negative 3 or negative 1 times 3. Does any of those sum to 4? No. So there's no, so it's not factorable. So that was quick. Didn't take me that long, guys, so therefore I'm going to use what? Quad formula. Okay, and for those who forget, I'm just going to put down what A equals, B equals, C equals. So A equals 1 right there, B equals 4, positive 4, right? And C equals negative 3. We're going to plug them into this expression, quadratic formula. So x equals negative b plus or minus the square root of b squared. So that's 4 squared minus 4 times a times c all over 2 times a. Okay, use your calculator, plug this in and simplify it. So you should have negative 4 plus or minus, get the value under the square root. It's root 28 divided by 2. Because, folks, I notice here in my numerator denominator that I can see I've got something divisible by 2, I'm going to look to take a factor out of my square root to simplify, because that makes the question easier. So it's going to be negative 4 plus or minus, I'm going to go 4 times 7 under the root, because I'm going to simplify my radical, as you were taught to do. I know it takes an extra step. But if you can't see a square perfect canceling or a canceling out, then you don't need to bother with this. So I bring my root 4 out, becomes root 7. Notice here, folks, I could now cancel because 2 goes into 2 once and in there negative 2 times. So x equals negative 2 plus or minus 7. Now that it's simplified, which would be your full marks, my graphic or my smartboard's going crazy on me. Now you can break it into its 2 parts. So either x equals negative 2 plus 7. So x would equal, if you plug in your calculator, I apologize, root 7. Where did my root go? Sorry, guys. Plugged it in your calculator, 0.65. Or over here, x equals negative 2 minus root 7. So x equals negative 4.65. Okay, again, circle your 2 answers. And you know what? You should feel good about getting a decimal answer because you told me, hey, it wasn't factorable with whole numbers, so guess what? We went to the quadratic formula. Okay, so that would show you 2 roots. Okay, all right, flipping to the other page. Another option I have is what's called the number of roots. Okay. And that's when you would use the discriminant. It's the part under the square root sign of your quadratic formula. Again, you don't need to memorize this because it will be embedded in the quadratic formula that's on your formula sheet. Okay? So b squared minus 4ac is what we're looking for. And just remember, for the number of roots, you can either have 0 roots, 1 root, or 2 roots. Make sure you know how to draw each of them. And the discriminant can be, if it's greater than 0, it means under the square root. If you're doing quadratic formula, you know you're going to have 2 roots. If it equals 0, that means your square root's going to cancel completely, and there won't be 2 options. And if it's negative, which is negative here under the square root when solving, then you know there's going to be no roots. All right. We also threw in a couple algebraic simplifications with this to determine k, values of k when we did this. So let's take a look at doing this. All right. For this example, determine the values of k given that each has no roots. So no roots means the discriminant has to be less than 0. So I'm going to write b squared minus 4ac has to be less than 0. Okay, everybody okay with that? All right, let's sub in the values that we know. Okay, so b in this point is k, so we're going to go k squared minus 4 times a. I apologize, that should be squared up there, guys. Okay, so 4 times a, which is 1, and c, which is 5, is less than 0. Okay, let's try to simplify this. So k squared minus 20 has to be less than 0. Oh, not less than equals then, just less than. My fault. Okay, then to solve this, k squared has to be less than 20 when you bring it over. And to get k, you got to do the square root. So k has to be less than the square root of 20. When you take the square root, don't forget it's plus or minus. Okay, So those are your two options. Either k is less than positive 20 or less than negative 20. All right, next example. Again, it tells us that has no roots, so b squared minus 4ac is less than 0. But now we've got to sub in different parts, okay? So in this case, b is 5, so we're going to go 5 squared minus 4 times a, which is 1, times c, which is k, is less than 0. So you've got 25 minus 4k is less than, my fault, I keep doing that, less than 0. Okay, now be careful here, folks, when you do something here, not the next step, but the step after. Leave the negative 4k there, and bring the 25 over, and it's going to become positive. It's already negative, sorry, it's positive, it's going to become negative over here. Remember, ladies and gentlemen, that when you are dealing with inequalities, that means greater than or less than signs, and you're dividing by a negative, do you guys remember what you have to do? You have to switch the sign. Okay? All right? Okay? So you're going to end up with k being greater than 25 over 4. Okay? All right? I want to show you another option here, folks. Or, if you wanted to leave it from this step here, folks, if you wanted to leave the 25 there and say, hey, this is negative 4k, I'm going to bring it to the other side. It's going to become positive 4k, which is fine. If you're not dividing, you're moving a term over. Then you divide both sides by 4, and you're going to get 25 over 4 is less than k. But put k first. K has to be greater than 25 over 4. So you decide which method you like there. Okay? All right, number 5, and our last kind of one we're taking a look at. Linear quadratic systems. Find the intersection points. Okay? So, ladies and gentlemen, if you are asked to take one linear, and look at this example here, you can tell this is the linear one, because it has no exponents. You can tell that the first one is a quadratic because it's got an exponent of 2. Okay? That what we're going to do here is we're going to, in order to find the intersection points, you're going to let f at x equal g at x. Check your unit test on this one. I know we did one like that. Okay? So we will say negative 2x squared plus 3 equals 0.5x plus 4. And then what do we need to do? And then we have to solve. But in order to solve, we have to get 0 on one side. A is negative on this side, so I'm going to move everything over to the right side. So it's going to be 2x squared plus 0.5x. And when I collect like terms with my constants, I'm going to have plus 1. And then we have to solve for x. So we can either factor or use quadratic formula. As soon as I see decimals, ladies and gentlemen, and I can't get rid of them, I'm just going to use quadratic formula. Okay? So we're going to sub this into the quadratic formula. So x equals negative 0.5 plus or minus the square root of 0.5 squared minus 4 times 2 times 1, all divided by 2 times 2. Okay? All right. Plug that in your calculator, folks. And under the square root, I get negative 7.75. And what do we want to remember about that, ladies and gentlemen? If it's negative, therefore there are no roots, because it is negative under the square root. That doesn't mean there's no x-intercepts. That means that these two will not intersect. Okay, so therefore f at x and g at x will never intersect. So it's a case like, if here's your graph, folks, maybe your quadratic's going up way over here, and then maybe your linear's going, I'm just trying to see what the linear looks like. Maybe it's going like this, and they never cross, right? Okay? right? Well, if you wanted to be accurate, let's be accurate, because we can. All right? So what do we know about the linear? About the linear, we know that the y-intercept's at 4, and we know it opens up, and it's a little wider. Okay? So I apologize. Let's take a look. The linear, our y-intercept is 4, and our slope is 0.5, which is 1/2. So you go up 1 over 2, up 1 over 2. So that's my linear g at x. Okay? So that's g at x expression with an arrow. Okay? Whereas when I look at my quadratic, I know a is negative, so it's opening down. And my vertex is at 0 and 3. Okay, so 0 and 3, and it opens down. So see how they won't intersect in this case? All right. I would like or prefer, ladies and gentlemen, you to solve the algebraic method. However, if you did show graph, you would still get partial marks, okay? All right, and if I don't give you a graph, I'm expecting you to use the quadratic formula after you've let each equal each other. However, if there's a graph there and that's a method you choose, you just say, I chose by graphing it. Make sure you explain how you graphed each line by telling me your step pattern or your slope, y-intercept method, etc. All right, folks, here is your homework for today, page 206, number 9 to 14, 26 to 30, and 33A. Note number 12 that profit is the revenue minus the cost, which is the price times the number of passengers, subtract the initial plus the price per passenger. So to help you out with that question, I'm just going to show you the initial substitution because it is a little tricky to figure out that word problem. So I'm going to give you a hint here. So please come back to this when you do your, ladies and gentlemen, when you do this problem. Okay, so I think X represents the number of either price increases or something like that. You'll figure it out when you see the example, because I don't have it open in front of me right now. Okay, and then don't forget it says to maximize profit. Is what the problem question is. You need to A, simplify. So simplify this expression, and then B, do what? If you want to maximize the profit, you need your maximum, so then you're going to what? Then complete the square. All right, folks. That is a long lesson today. I know we spent a lot of time on quadratics, so hopefully you've got a good grasp on that. Please come see me for any help, and have a great day, guys. Battle on.